Hello, I'm Hanson Lee and I'm doing the AP Physics 1 second semester FRQ2. So for 1, it's asking for the corresponding f of x graph according to Hooke's law. Hooke's law is that the restoring force of a spring is equal to negative kx. Let me draw what's given. If you just look at this as like y equals mx, and fs as y and x just as x, so the slope is just going to be a negative 1 and there's going to be no shift up or down, so it has to touch 0. And at max at max amplitude, it should be max spring force, but in the opposite direction because it wants to go towards equilibrium. So your graph should look like something like that. For B, asking for the x of t, v of t, and a of t graphs. So let me just draw all of those real quick. Okay, so it's gonna start initially compressed. So right there is just where I'm gonna put like negative a. So and it's asking for t. 2 t's. As in period, by the way. So it should go to the same point at the end of the period, and at a half it should go to the opposite. So it should go to the opposite max. So it should look like this. Cosine graph. Sorry, I'm going all over the place. It should look like this cosine graph. And v, so if this is cosine, this has to be sine. And you can tell that at this point, the tangent line of the slope would be flat. So it start at 0. And you can tell that this curved line at a tangent point would be positive and max. So like right here would be max, and here the tangent line for the slope would be flat. So it should just continue like that, because you can see that this becomes negative and this cycle continues. So it should be like this sine graph. Okay, you can see that. Nice. So for the A graph, it's just going to be the opposite of the X graph. Because it would be going towards equilibrium, which is the opposite of where A would, like the amplitudes would be. Okay, so those are the 3 graphs. Student claims that if the compression distance doubles to 2a, then the max speed during oscillation will also double. We can just use ME. We can use because the total energy has to be conserved, as in MEI equals MEF. We can just use a point where all of the energy is the spring force, the restoring force, and then a point where all of the energy is the kinetic energy. So this would be 1/2 kx squared equals 1/2 m v max squared. X max is, I should have just put a. I'm gonna put that right now. A squared equals 1/2 m v max squared. So you can cancel out 1/2 on both sides and then divide by m on both sides. So v max squared equals k a squared over m. I just like it, like the equal thing on the left. And then you have to square root both sides. So v max equals square root k a squared over m. And a squared can leave because it already has a square, but it's just gonna leave as a. So v max equals a square root k over m. And the student claims that if the distance is double to 2a, so 2a, well, it's basically 2 times everything here, so just 2 times this, because you know v max is all of this, and you can just make the 2 times 2a equals to 2 times all of this, because a is included. So this means that v max will also double times 2. So agree because v max is impacted directly by a and doubles alongside with it. Okay, now D. Student claims that compression distance is double to 2a, then the oscillation frequency f will quadruple. So the formula for f is 1 over 2 pi square root k over m. But as you can see in here, there's no mention of a or x, so 2a wouldn't change the frequency at all. So disagree because frequency is only impacted by k and m, which would change. So for E, prove that the velocity of the block can be calculated using this function. We can do mechanical energy again. So the function given has a squared minus x squared, which means there's gonna be 2 spring potential energies and then Ke. So if we start at the max spring energy, I'll put max here too on these, because now we actually have like a different PES. This is just gonna have PES but not max, just at that position, and KE at that position. This is gonna be 1/2 K X max, which is just A, so A squared equals 1/2 K, and then this is gonna be like the actual distance from equilibrium, so X squared plus 1/2 mv squared. So you can take out 1/2 from all of these, so Ka squared equals Kx squared plus mv squared. And you're trying to find v, so you have to move over kx squared. So ka squared minus kx squared equals mv squared. You can factor out a k, so k a squared minus x squared equals mv squared. You can divide by m. So k over m a squared minus x squared equals v squared. And you can see it's already trying to look like it. So if you square root both sides, you have v equals square root k over m and of a squared minus x squared. But square root k over m is already something, which is omega. So v equals omega. But the other things still have to stay in the square root, so it'd still be square root of a squared minus x squared. And the reason why you add the plus or minus is because the velocity can switch directions. It just depends on like what it's coming from. Is like the negative or positive. It just means it's opposing it's going in the opposite direction of the amplitude. I mean, so this is how you get that formula. Okay. Let's do f over here. So this one will be towards the equilibrium position, this dot. So I'm just gonna make FG and FN the same length because it's just laying flat. And since the velocity is going right, that means FK has to oppose it and go left. And since it hasn't reached equilibrium yet, and equilibrium is on the right, that means the restoring force has to go right because the spring force always goes towards equilibrium. And for away from the equilibrium position, Fn and Fg are still going to stay the same. It's not going up or down. And since the velocity is still going right, Fk still opposes it and goes left. But now that it's past the equilibrium point, the restoring force will also go left because the equilibrium point is on the left. Okay, G, let me do it right here. Let me draw what's given first. Okay, so this is what is given. I'm gonna draw like the marks for x, which would be negative 2a, negative a, and then a, and then 2a. So I have to do these in different color. Scenario 1, it just begins at compressed at negative a. Should go to the same point because that's what period is. And it should just go to positive a in between. So it should look like this cosine graph like that we did last time. But now, scenario 2, it's being compressed to negative 2a. And since energy is conserved, it has to go all the way to 2a. And has to reach the same point in the period. Remember that their periods is the same because t is related to f, and f is not impacted by an x. So it's just going to be like a dilated version of scenario 1. Okay, there. I know it looks a little weird. So scenario 1 is the blue one, and scenario 2 is the red one. Okay, so now a 2m block will drop on the m block, and it wants me to find the numerical value of the ratio T3m over Tm. So I'm going to be doing this here. So we can choose the same formula. Tm equals 2 pi square root m over k and T3m equals 2 pi square root 3m over k. So T3m divided by Tm, same thing as 2 pi square root 3m over k over 2 pi square root m over k. So the 2 pi's are going to cancel out. This is basically square root 3m times square root of 1 over k. So, and this is basically that 2, but times m. So, this is going to be, the square root k is going to be canceled out at the bottom, which would make this square root 3m over square root m, and square root m's cancel out. So it'd be square root 3 over 1, which is square root 3 as the ratio of T3m over Tm. Okay, I'm going to flip to the back to get more room for I. So how does the amplitude of oscillation A3m of the 2-block system compare with the original amplitude AM of block M alone? So we can use the energy formula because I know that involves amplitude, so we can just reuse what we did here. So PES max equals KE max. Remember that we're using, because energy is conserved, and at one point it's going to be all PE and at one point it's going to be all KE. And this would be 1/2 K A squared equals 1/2 M V max squared. So these cancel out, so KA squared equals M V max squared, which means that A squared equals M V max squared over K, which means that as you square root both sides, A equals square root M V max squared and all over K. Okay, so what is changing when 2M drops on M? So M is definitely changing because it's going to stick together and become 3M, but V max is also going to change, and here's why. So the net momentum is going to be um equal, the net initial momentum is going to be equal to the net final momentum, because it is always for a collision in so far. But yeah, net momentum, whether it's an inelastic or elastic, net momentum is always conserved. But the net momentum in the x direction is what we're going to focus on, because the velocity is going in the x direction. So this would be m and then v max plus, you can't add the 2m because its velocity is going down while this is going horizontally, so you're adding 0 basically. You're adding 0 momentum in the horizontal direction. However, since it sticks together, the new total mass would be 3m, and you have to calculate the new VF. So okay, mv max equals 3m VF divided by 3m on both sides. So VF is now Vmax over 3. What this means is that if we make a new equation using this, A equals square root, remember our new mass is now 3m because it sticks together, but our new Vmax is or our new VF is Vmax over 3 still squared over k, which is A equals square root 3. You can square both sides by distributing. Square root the top and the bottom by distributing, which makes this 9. 3 times 1 over 9 m Vmax over k. Basically, this is 1/3 m Vmax over k squared. So if you're multiplying the top by a fraction, it's just going to get smaller, which means that this A of, okay, so this is the amplitude of oscillation of 3m, like when it sticks together with the 2-block system, and this is of m. So this is going to be more, so A 3m is going to be less than A of just m. I guess check. Okay, let me say everything that I just said into a paragraph response. Okay, when the 2m block lands on the m block, the velocity and total mass changes. The velocity changes because the momentum horizontally stays the same, but the total mass increases. This means the velocity has to decrease. The amplitude is impacted by m and v, but not k. But is not changed by k. Changed by k because k stays the same, because it's the same spring. Since the velocity becomes a third and then is squared, it becomes a ninth, or 1/9. Even though the mass is 3m, 3 times 1/9 is 1/3, so less than 1, the original amplitude. So AM is greater than A3M. Okay, I hope I got all the points.